Hello everyone, welcome to Al7075 Engineering Research. I'm Nitin, my student number is 6312718. I'm from University of Wollongong and I'm currently studying Masters in Innovative Manufacturing. Today I'm going to talk about my research on the formability of ultra-thin gauge aluminium 7075 T6 alloy by reverse hydroforming technique. So the contents of my presentation includes the introduction that talks about the thin sheet metal and its gauge, fabrication process of the industrial processes for the fabrication techniques used, the defects like a microstructure and all the defects involved in the sheet metal, the previous conducted studies, the research question, my proposed design for forming ultra-thin gauge sheet metal, the expected results, and also the references used in the study. So what is sheet metal? Sheet metal is an industrial forming process of converting metal into thin sheets. It can be cut into various shapes and sizes depending upon the requirement. The thickness of the sheet metal is purely dependent upon the processes used for the fabrication, and it is measured by the term called gauges. So gauge is nothing but the thickness of the metal and the thickness of the gauge is the same. So higher is the gauge, higher is the thickness value. So the sum of commonly used materials in sheet metal are aluminium, brass, copper, and stainless steel. These are of different grades and they provide a varied mechanical properties. So the material used in my design is aluminium, and it is of the grade 7075. Coming to the applications, sheet metal, it finds the application in the automotive industries, aerospace industries, design and architecture. So the fabrication processes. Many industries conduct a lot of fabrication process for the formation of sheet metal, whereas these are some of the processes involved. So the most commonly used process are multi-stage hot and cold rolling, hydroforming, incremental sheet forming, deep drawing, stamping, and forging. Among these, hydroforming, stamping, and forging are some of the most commonly used methods for the fabrication of sheet metal. Coming to the defects, as you can see, these are all some of the defects that occur in sheet metal. So this is the microstructural defect, this is the wrinkling, this is cracking, surface roughness, and also one of the main important defects that has to be covered are size defects, which have not been covered in most of the researches, and in my research I'm going to focus on the size defect. Coming to the previous studies, these are the previous studies that were conducted for the research. Among these, the most of the commonly found research idea was that the thickness distribution of the sheet metal was achieved in most of the researches, and it was covered in all the three research. So I'm not going to include the thickness of the sheet metal in my research. So the most common gap which was missing in all of these research was that high discharge was required to produce deep drawn parts, which I'll be focusing on now. So coming to the research question, the aim of my research is to suggest a forming technique to produce the sheet metal and to conduct an in-depth analysis on the microstructural and internal characteristics of the metal. So the design proposed uses the material aluminium 7075 T6 as I mentioned below. So followed by recrystallization as the metal processing, and the fabrication process is reverse hydroforming technique, followed by an in-depth analysis of finite element method by using ANSYS as my software. So the expected results in my research is that an uniform distribution of thickness is achieved, microstructural purity, which I would be getting by the recrystallization method, structural stability, good formability of the metal, the organized grain texture, and improved surface roughness, thereby increasing the mechanical property and the metallurgical property of my metal. So these are some of the common references used in my researches. Thank you for this opportunity. Thank you.